Good morning, everyone, and welcome back to Data Structures Theory session. Because of current situation, we are having this lecture online only, no physical mode for today. Let's continue our second unit, which is linear data structures and their representation. Well, we have seen simple queue and circular queue both. So if we quickly revise, then a simple queue is a kind of a linear queue, we can say, a sequential queue also. There are a few limitations on simple queue. So if you completely use your simple queue once, then you can not reuse your simple queue again. And if you do have few empty elements at front, you are not in a position to reuse those elements, right? That's the limitation of simple queue. We have seen that using this example, as you can see on your screen. Now, to overcome that problem, we discussed the circular queue also. In a circular queue, well, in terms of memory, it is no more than simple queue. It is same. We need one data array and we need two more variables, front and rear. And definitely in terms of memory, it is a sequential memory allocation, contiguous memory allocation. But to represent it, we draw this as a circle in a circular manner. And how do we have that behavior in a circular manner? For that, we go for modulo operation, as you see here. So to make calculations in a circular manner, we do use operation or the modulo operation. Now, with the help of modulo operation, we achieve the circular behavior, and then we have seen insert operation algorithm, delete operation algorithm, then change operation algorithm. Even we have seen display operation and other also. Now this is where we stopped. So we are done with simple queue, we are done with circular queue. It's your task, your takeaway task that you might have been implemented both the queues as a abstract data type, just like we see that in a stack. So create a separate implementation file, create a separate demo file, go for the menu driven code and demonstrate it, right? So all those things have been done till now. Let us have a look at one basic example of circular queue, and then we will continue for other types of queues. Look, if I want to draw us a very easy and simple question, then there might be a question like this. So what this says, it says consider a circular queue of size 5. So total 5 elements you can store inside your circular queue. And the current status is already given to you, where it says front is 2, rear is 3. Okay. Now here front is 2 and rear is 3 means it is considering 1, 2, 3, 4, 5, not 0, 1, 2, 3, 4, 5. Okay. So if you go for index, then it becomes 1 and 2. So if you go for index 0, 1, 2, 3 and 4, then this is going to be 1, this is going to be 2. That's where your front and rear is pointing to right now. Okay. So this is the current status given to you already. Now these are the index values. And then based on the current status, it says perform the below operations. Given operations you have to perform there. And let us see what happens if we go and perform these operations. So what is the current status? Your front, as per index, your front is 1, rear is 2, and there are 2 elements inside your circular queue already, which is L and M. This is already there. Now it says you perform the insert operation. Well, insert will always be performed on the rear part. So rear plus plus and then modulo max. So if rear is 2, then it becomes 3. And at rear place, we are going to insert new data N. No change in front. So we have inserted N. Then it says insert O. Well, just you increase your rear, make it 4, and wherever rear is pointing to, you store your new data O. no change in other elements, and front is also as it is. So one by one you have to perform those operations, and every time you have to display, or every time you have to show what is the status of your queue. So half mark or 1 mark operation can be asked. So next one is insert P. Now what is your rear? Rear is 4. 4 plus plus is 5. 5 modulo maximum size is 5. 5 modulo 5 is 0. So rear becomes 0. And at rear place, at 0th place, you are going to insert your P. No change in other elements. Okay. Then it says you have to delete. Well, it's very simple. Delete one element from front. So your front is 1, so you are going to delete whatever data is at index 1. And then you increase your front also. So your front becomes 2, rear as it is, and no change in other elements. Okay. Then it says one more delete operation. So wherever your delete is pointing to 2, index value 2. So from index 2, you delete an element and you increase your front. So front becomes 3, rear is 0, no change in other elements. Remember, this is a circular queue. So whenever you increase your front or rear, we always do modulo max. But if it is within the range of max, then modulo operation is not going to make any difference. Yeah. So the next operation, it says insert Q. Now insert operation is always being done on rear. So rear becomes 0 to 1, and wherever rear is pointing to, you are going to insert your data Q. No change in other data as well as front. And the next operation is R. Insert R. So again you update your rear. Rear becomes 2, and at that place you are going to insert R. No change in other part. Now at present your queue is full. If you still go and say insert S, then this is not possible, because the current status of front and rear is what? Front is exactly rear plus 1, and that indicates overflow message. So this is how your circular queue will work, and insert and delete operations you can perform on a circular queue every time you trace your circular queue and you draw the current status of your circular queue, right? So this is the example of working of a circular queue. Any question till now? Any doubt or query till now? Okay. Well, so that's the example of circular queue. Now let's continue and have a look at few other types of queues. The next one that we want to have a look at is a D queue. It is also called double-ended queue, or it is also called DEQ. Okay, DEQ, DQ, or double-ended queue. Also written as DQ. Okay. Now the word DQ has been generally deprecated, because technically in a literature it is also called delete operation, remove an element from queue, right? So DQ दो जगह पे यूज होता है, that's why DEQ double ended queue is okay. DQ को हम rarely यूज करेंगे, जैसे मैंने ऑलरेडी आपको इंसर्ट डिलीट के वक्त भी बताया था, राइट? लेकिन अब ये याद रखो, अगर डी क्यू बोला है तो सिंपल क्यू के साथ डिलीट ऑपरेशन या तो फिर डबल एंडेड क्यू हो सकता है. नाउ how DQ works and what it is actually. So let us see what is the double-ended queue. So DAQ or a double-ended queue is a data structure where you can insert or delete element from any end. कहीं से भी आप insert delete कर सकते हो. So in that case, if you say this is your double-ended queue, both the ends are open. Now in general, what we do, we insert from the end and we delete from the front. Okay, in and out. Now this is a simple queue, but in double-ended queue, what you can do is you can insert from front also and you can delete from last. If this is your front and if this is your rear, then you can perform insert and delete operation from any end. कहीं से भी आप insert या तो फिर delete कर सकते हो. That's why it is called double-ended. दोनों end जो है वो आपके लिए open है. So it is called double-ended queue. Now why do we need this one? Look, अभी भी इसका जो first come first serve वाला behavior है, it is open, it is performed here. आप बीच से कोई एलिमेंट नहीं निकाल पाओगे. आप एलिमेंट या तो फ्रंट से या तो रियर से निकाल पाओगे. Now, so what is the benefit of double-ended queue? So double-ended queue can behave like a queue. अगर आपको सिंपल क्यू की तरह यूज करना है तो करो, या तो फिर वो स्टैक की तरह भी यूज हो सकता है. So if you focus on this part only, then it works like a stack, right? So double-ended queue provides you both data structures, queue and a stack, in a single data structure. So that's one kind of a behavior, and you can use your double-ended queue in multiple places wherever you need your both ends to be open for any kind of operation to be performed. Okay, so this is what the double-ended queue is. कहीं से फ्रंट से या रियर से कहीं से भी इंसर्ट करो, कहीं से भी डिलीट करो. बट इसका मतलब तो ये नहीं है कि रैंडमली आप इंसर्ट और डिलीट ऑपरेशन परफॉर्म करोगे, राइट? सो व्हाट हैपेंस हियर is we define where and what operations we do. So a simple queue जो है उससे first in first out से double-ended queue जो है वो थोड़ा differ करता है. Now how? So in this one we impose few restrictions. So if elements can only be added to one end and removed from the other hand, ये हो गया आपका simple queue, right? लेकिन अब हम यहाँ पे क्या करेंगे, हम in या तो फिर out दोनों में से एक एक करके ऑप्शन देखते हैं. Let us see if I impose restrictions on in. So I say input restricted double-ended queue. Okay, input restricted double-ended queue. तो यहाँ पे मैं restriction क्या डालूंगा? I am going to impose few restrictions on insert operation, where it says insertion can be done from the one end only. कहीं एक तरफ से ही आप insert कर सकते हो. Deletion can be performed from both the ends. Okay, deletion can be performed from any end. Insertion can only be performed from the one side. That is input restricted double-ended queue. So same way, if you impose your restrictions on output, then you can say insertion can be done from the both ends, but deletion can be performed from the one end only, right? Well, in this case, again, when you say input restricted, तो वहाँ पे आपको दो ऑप्शन मिलेंगे, and that looks something like, if you have input restriction, मान लो कि and से input किया, okay, इन, कहीं से भी आउट करो, नो प्रॉब्लम. ओके. और एक ऑप्शन भी मिल सकता है, यू कैन इंसर्ट योर एलिमेंट्स फ्रॉम फ्रंट but you can out from any end. So this is one option, this is second option. So insertion from rear, deletion from both. That's your first operation, first option. Another option is insertion from front, deletion from both ends. That's your second insert restricted or input restricted DQ. Now same way, what you can have is you can have two different output restricted queues. Okay, where you can say insert from both the ends but delete from rear only. That's your first option. Second option can be insert from anywhere but delete from front only. So दो option वहाँ पे भी आपको मिल सकते हैं. So if you do have double-ended queue, then you actually have 4 different types when you impose few restrictions on input or output operation. Right? So read this thing carefully and try to understand. I'll pause here for 1 minute. Yeah, okay. So that's what the double-ended queue is. So फिर से एक बार समझते हैं. Double-ended queue means both the ends are open to perform any kind of operation. But in that case, we are not going to randomly operate it. What we can have is we can have few restrictions on either input or output. And based on the restriction that we impose on the input or output, we have 4 different kinds of double-ended queue. So insert from rear only, deletion from both the ends. That's your first option. Insert from front only, deletion can be done from both the ends. That's your second option. So those two options were input restricted queue, double-ended queue. Now if you go for output restricted double-ended queue, so out from rear, in from both. Or else you can go for out from front, in from both. So 4 अलग-अलग तरह की double-ended queue आप use कर सकते हो as per your need. So what kind of a need or what are the examples that you can use to understand where we can use double-ended queue? So let us have a look at one example here. We can use a double-ended queue. Okay, we can use double-ended queue to check whether the given string is palindrome or not. Given string is palindrome or not. So how can we do that? So it says you use input restricted double-ended queue. You use input restricted double-ended queue. So कैसा होगा input restricted double-ended queue? We insert from rear only. Okay, insert from rear only and out from both the ends. Okay, now this is gonna be your input restricted double-ended queue. We have used the first option. So what it says, you insert your entire string in this input restricted double-ended queue. एक बार अपनी पूरी string जो है वो इसके अंदर डाल दो. And then it says perform a delete operation on both the ends and compare those characters. So let's take an example. You take a double-ended queue, okay, which is input restricted, and we are inserting from the rear. Initially your queue is empty, so front is -1, rear is also -1, and then when you start when you start inserting your queue, let's say we use radar. I want to check whether this is a palindrome string or not. Okay, so what we can do is we can start inserting our entire string character by character in the given queue. So first one, let's say this is your queue index. Initially your front rear is -1, and when you go and insert your first value, you are going to make these two 0. Okay, so where is your front? Your front is at 0, rear is also at 0, and you are going to insert R. And then upcoming characters will be inserted one by one. Your rear will be updated, and at the end your rear will be pointing to 4. So you have inserted your entire string in double-ended queue. We have inserted only on rear. Okay, जब भी मैंने insert operation perform किया, I have made R++, which indicates I have inserted my data from rear only. And then what it says, you can perform your delete operation from both the ends. So what it says, you perform your first delete operation on front and rear both and check what is the character. R and R, it is equal. Okay, now whenever you perform your delete operation, front is always gonna be plus, rear is always gonna be minus. So the next delete operation, it says you perform delete operation on both the end and see what is your character. If it is equal, you will continue, right? And you are going to update your front and rear. And then again it says you perform a delete operation and check what is the character. So this is how you can use double-ended queue to check whether your given string is palindrome or not. Palindrome आगे से और पीछे से दोनों string equal बनती है. So it's kind of let's say radar, Nayan. Gujarati students will know that limdi game gadi mali and so on, right? Well, so all those are the palindrome strings, and if you just want to check whether the given string is palindrome or not, then only 2 steps. Enter your entire string, insert your entire string in input restricted queue. Then you perform delete operation on both the ends simultaneously and verify if both deleted characters are equal or not. If your queue becomes empty and all the characters till now are equal, then string is palindrome, otherwise it is not. Right? So this is one example of making use of double-ended queue. So if there is a short note kind of if there is a short note asked on double-ended queue, then what you have to do is you have to write double-ended queue is a queue where we can perform insert and delete operation from both the ends. Now when we impose few restrictions on insert or delete operation, we can have types of double-ended queues: input restricted queue, output restricted queue. Then you describe what is input restricted, what is output restricted. Then you describe its 4 different types, and then you give one example where we can use it. So that completes your at least 6 marks, or not more than that, more than 6, then at least 4 to 6 marks question. Right? So that's double-ended queue. Any queries or doubt till now? Now, simple queue and circular queue has algorithms for insert, delete, pick, change, display operations. But double-ended queue and priority queue does not have any algorithm here. It is just a topic, but it can be asked just as a short note. Okay. So double-ended queue and priority queue does not have any operations or any algorithms in your syllabus. Still, if you want to implement it, you can just use your mind. आपने circular queue और simple queue कैसे implement किया था? Make use of that understanding and implement these things. You can do it. Well, so that was double-ended queue. Next one is the priority queue. Let us see what is priority queue and how it works. So as its name suggests, priority. कभी ऐसा भी बनता है कि एक से ज़्यादा टास्क आपके पास आते हैं. You cannot always go for first come first serve. अगर हायर प्रायोरिटी टास्क आपके पास आ गया तो आप उसको पहले प्रेफरेंस दोगे. राइट? जैसे टिकट विंडो पे आप लंबी लाइन में खड़े हो, लेकिन कोई अथॉरिटी आ गया, हायर अथॉरिटी से कोई आ गया, तो उसकी टिकट डायरेक्ट निकलेगी. Right? So something like that. What is a priority queue? Priority queue, again, we can say it's kind of a abstract data type we can implement, just like simple queue, circular queue and all. So it is going to be just like a regular queue data structure. But additionally, into that simple queue, each element has its own priority associated. हर एक एलिमेंट को उसकी एक प्रायोरिटी असाइन की होगी. So let's say we have some data. We have a data called A, B, C, D, E and all. But here, along with data, along with that data, we have the priority associated P1, P2, P3, P4, P5 and so on. And if we insert all these things in a queue, then we have front and rear also. We have front and rear. Now definitely we need to maintain priority. We need to store priority of each and every element somewhere so that we can check which one is having higher priority. So in a priority queue, it is possible that element D will be deleted before all other elements. Although it is not on the front, remember, although element D is not on the front, it may be deleted first just because it has the highest priority. तो फिर ये implement कैसे करेंगे? मतलब this is what we want to achieve, but अगर इस तरह से हम front और rear रखते हैं तो हमें कैसे पता चलेगा कि P4 को पहले निकालना है? So generally priority queue works just like a simple queue, but along with that we have the priority associated, and we need to check those priorities. Based on the priority we are going to perform the operation, right? So for that, what we can do is, let us try to understand exactly how it works, and then we will try to find out how we can implement priority queue. So what are the rules for priority queue? Well, it's very simple. In priority queue, every element is going to have some priority associated, and the element with the highest priority is going to be served before other which are having low priority. So higher priority is going to be served first. Now what if you have multiple elements having the same priority value? So if two elements have the same priority, then it goes for first come first serve basis according to their order in the queue. जो पहले आया वो पहले, अगर सेम प्रायोरिटी है तो जो पहले आया उसको पहले सर्व करेंगे. So major two rules we are going to remember. Based on the priority value, you are going to serve the element. If multiple elements are having same priority, then go for the first come first serve basis. Okay. So let us see how we can achieve that. One way to achieve this thing is you follow the two-dimensional array where each row is indicating the priority value. Okay, each row is indicating the priority value. So if you say that this is what the data you have which you want to maintain using priority value, so आप check करोगे कि कितनी priority values है. 1 2 3 4 3 3 4 मतलब repeating 4 priority value है आपके पास. Then you are going to have your priority values 1 2 3 and 4, and you are going to have a two-dimensional array. Number of rows are equals to priority values, number of priority values. Number of columns are going to be the size of your queue. तो यहाँ पे कुछ इस तरह से होता है कि हर एक रो, every row behaves as a separate queue. अब वो सिंपल भी हो सकता है, सर्कुलर भी हो सकता है, बट यहाँ पे हर एक रो जो है वो एक अलग क्यू की तरह बिहेव करेगा. दैट मीन्स every row will have their own front and rear values. हर एक रो के लिए आप उसका फ्रंट और रियर अलग से लोगे यहाँ पे. So what you need is you need a two-dimensional array, and for every row you need front and rear values. Okay, each row behaves like a simple queue or a circular queue here. So हर एक रो का खुद का फ्रंट और रियर मिलेगा, and that's how we can implement priority queue. Two-dimensional array and then number of front and rears. इसको आप इस तरह से भी कर सकते हो. Two-dimensional array, एक दो two-dimensional array ले लो और दो one-dimensional array ले लो. Those are fronts and rears. Okay, that can also be done at the time of implementation. Now how it works. So we'll go for the one by one insert operation. The first one is insert A with priority 1. So what you are going to do is you are going to check where is your priority 1, what is the front and rear value. So initially it was -1, everyone was -1. Then what you will do is you will make it 0, and at a rear place, जहाँ पे भी rear point करता है, at that place you are going to insert A. So if this is 0 1 2 3 4 index values, then you are going to insert A at a 0th place. Okay, because it is a priority 1, first row के अंदर rear जहाँ पे भी point करेगा वहाँ पे A insert करेंगे. Then the second value, insert B, but it has priority 2. So in priority 2, front or rear -1 से 0 हो जाएंगे, and at that place you are going to insert B. Then for C, well, it's priority 3, so front and rear are gonna be 0, and at 0th place you are going to insert C. So every element, every data is being inserted inside your priority queue based on the priority value. The fourth one, D, is going to be inserted at 4th row. Okay, because it has priority 4. Now the next insert operation E is gonna be performed on the 3rd row because it has priority 3. At that time your rear is 0, so it becomes 1, and then you are going to insert E here. जो उसकी प्रायोरिटी वैल्यू है उसके बेसिस पर उसकी पर्टिकुलर क्यू जो रहेगी वहां पे आप उस डेटा को इंसर्ट करोगे. So your F is definitely going to be inserted at this one, 3rd row, index 2. And then the next one, G, well, G is going to be inserted in the 4th row because it has priority 4, G here. So this is going to be your status of priority queue when you insert the given data. When you insert the given data in a given sequence. Remember, sequence does matter here. Now, if any point of time you perform a delete operation, then delete will always be performed on the highest priority value first. अगर 1 को आप higher और 4 को आप lower मानते हो, then it is always going to be deleted. A is always going to be deleted first. Okay, with priority 1 जितनी भी values हैं वो पहले delete होगी. And if you delete the last value, front and rear both becomes -1 again. Right? Now, once your priority value 1 queue is empty, priority 1 का जो queue है वो खाली होगा, only after that you will go to priority 2, and you will delete B. उसके बाद ही B delete होगा. So next operation, delete operation आपको B देगा. Then next delete operation आपको C देगा. Now third priority value is not empty till now. अभी भी third row जो है means priority 3 का जो queue है वो खाली नहीं है. So next delete operation will give you E. So पहले आपको A मिला, then you have B, then you have C, then you have E. Next you will have F, then you will have D, and at last you will have G. So this is going to be the sequence of your deleted items. Because A is having highest priority, पहले वो सर्व होगा. Then you have second priority B, तो B delete होगा. Then you have priority value 3, कहाँ पे है? C, E और F. यहाँ पे है तो C, E, F पहले delete होंगे. Which means if you see here, C is deleted, D के बजाय E और F पहले delete होंगे, पहले वो served होंगे, and D पीछे जाएगा. So एक अलग तरह से आप देखो तो ये क्या हो गया, आपका जो डेटा है वो प्रायोरिटी वैल्यू के बेसिस पर सॉर्ट हो गया. You are going to sort your data based on the priority values. Okay, and that's how priority queue works. और ये हो गया array representation of your priority queue. 2-dimensional array use करके हमने priority queue बनाया. If there is a short note on priority queue, then you can say what is a priority queue? what are the rules, and how you can implement priority queue using array, where you need to use two-dimensional array. Each row will represent one priority value, and every row will work like a separate queue. So every row will have their own front and rear values. Okay, just a minute, guys. Yeah, so this is priority queue we have implemented using array, 2D array. Now priority queue को आप linked list से भी बना सकते हो. You can also create your priority queue using linked list. अब linked list detail में तो हमने नहीं पढ़ा, लेकिन unit 1, if you remember what is linked list, we know that. So if you want to create a priority queue using linked list, तो आपको क्या करना होगा? Well, every node in a linked list will contain your data as well as a priority value. Your data as well as a priority value. And those nodes are sorted in descending order of your priority value. Okay, so it's gonna be something like when you start inserting your first data or first value, you will have data, you will have priority value, and you will have next pointer. So you will have your data, you will have your priority value, and you will have a pointer. Okay, not a reference. You will have three portion: a data portion, a priority portion, and a pointer portion. So when you start inserting your first value, so your data is A, your priority is 1, and this is the only value you have, so the pointer is going to be null. Pointer is going to be null. Now let us assume that 1, 2, 3, and 4, 1 is high, okay, and 4 is low. 1 is the highest priority, 4 is the lowest priority. If this is the case, तो जैसे ही हम next B को insert करने जाएंगे, तो क्या करेंगे? We are going to insert a new node B based on the priority value sorted. So इसका अगर priority 1 है तो नया node उसके पीछे जाएगा. So we'll have a new node at the end. This is going to be B with priority 2, and this is going to be null, and this will be updated like this one. तो first node का pointer अब next node B को point करेगा. Now just like that, when you insert C, you will create a new node, and C will be inserted at the end because it has priority 3, but B pointer is going to be updated here. Now similarly, when you insert D, D has the lowest priority, तो वो भी last में जाएगा. D with priority 4 and null, and this will be updated. So what happens here कि 1, 2, 3, 4 priority value sorted रहेगी. So insert operation can be done anywhere based on the priority value, but delete operation will always be performed from the front, मतलब from the head. Linked list के केस में हम उसको head या start बोलते हैं. So delete operation is always gonna be performed from the हेड या तो फिर स्टार्ट। तो जब भी आप डिलीट करने जाओगे तो आपको हर बार ए पहले मिलेगा, राइट? वेल, if we see the further insert operations E, तो अब यहाँ पे देखो क्या होगा। Look, A is having priority 1 higher than 3, आगे बढ़ेंगे। B is having priority 2 higher than 3, आगे बढ़ेंगे। C is having priority 3 equals to 3, तो C पहले आया था, हम और भी आगे बढ़ेंगे। D is having priority 4 which is less than 3, तो D के आगे before D we are going to insert E, मतलब अब हमें यहाँ पे एक नया नोड इंसर्ट करना पड़ेगा E which is having priority 3, right? So where do we insert it? यहाँ पे हमें उसको इंसर्ट करना है। So we are going to update our pointers now. C next will be pointing to E and E next will be pointing to D. So we are going to update these pointers. नोड जहाँ पे भी है रहने दो, हमें सिर्फ ये पॉइंटर मैनेज करने हैं। अगर हम ये पॉइंटर मैनेज कर लेंगे तो हमें ये सीक्वेंस मिल जाएगा A B C E then D. So this is how you can implement your priority queue using linked list, where nodes are sorted based on the priority value. So next, जब भी आप insert F करोगे तो क्या होगा? You are going to update this link and you are going to insert your F after E. E will be pointing to F and then F will be pointing to D. और लास्ट में जब आप G को इंसर्ट करोगे, G is having the lowest priority and it came after D, तो आप क्या करोगे? You are going to update this null and you will insert your G at the end. Okay? So कुछ इस तरह से आपका प्रायोरिटी क्यू बनेगा यूजिंग लिंक लिस्ट, और हर बार डिलीट ऑपरेशन हेड से होगा। हेड जहां पे भी पॉइंट करता है वो नोड डिलीट करो और उसके बाद हेड को नेक्स्ट नोड पे लेके जाओ। सो अगर फर्स्ट टाइम डिलीट करोगे तो ए डिलीट होने के बाद हेड आपका चला जाएगा बी पे। सो नेक्स्ट टाइम डिलीट करोगे तो आपको मिलेगा बी, और बी अगर डिलीट किया तो हेड चला जाएगा सी पे, एंड सो ऑन. So you will have A, B, C, E, F, D, G, same sequence, and that's how you implement your priority queue using linked list. यहाँ पे first statement जो लिखा है that is important. Nodes will have data as well as priority, and all the nodes are sorted in descending order based on the priority value. Okay, so that's your priority queue. Now, priority queue कहाँ पे use होता है? Well, in your processor it makes use of priority queue, क्योंकि जब भी आप कोई भी टास्क परफॉर्म करते हो, प्रोसेसर तो वो सारी टास्क को वन बाय वन परफॉर्म करेगा, एक एक करके परफॉर्म करेगा। वो सिंगल कोर प्रोसेसर कैन परफॉर्म अ सिंगल टास्क एट अ टाइम। मल्टी कोर में भी आपके पास कितने कोर है, चलो उतने टास्क परफॉर्म हो सकते हैं एक साथ, उससे ज़्यादा नहीं। फिर भी क्या होता है, if your song if you are playing a song एंड कहीं से कॉपी पेस्ट किया तो वो कॉपी पेस्ट भी स्टार्ट हो जाएगा, राइट? एक और एग्जांपल दिखाता हूँ। लेट्स से यू आर वाचिंग अ HD मूवी, हाई डेफिनेशन मूवी, या तो फिर ब्लू रे मूवी देख लो। ब्लू रे मूवी चल रहा है आपका, एंड अगर आपने कॉपी पेस्ट या कट पेस्ट स्टार्ट किया तो कट पेस्ट रुकेगा नहीं, आपकी मूवी जो है वो बीच में अटकेगी बेस्ड ऑन योर रैम, अवेलेबल रैम। इसका मतलब क्या हुआ कि कॉपी पेस्ट को प्रॉब्लम नहीं होता, it is having the higher priority compared to playing your movie. इससे भी अलग एक एग्जांपल, मान लो कि आप विंडोज में हो, कंट्रोल अल्टर डिलीट जैसे ही आप प्रेस करते हो, बाकी सारे टास्क साइड में आपको टास्क मैनेजर ओपन मिल जाता है. So that's another example, control alter delete, that is having the highest priority compared to other operations. Now if you विंडोज में अगर आपने ऑटो रन चालू रखा है, ऑटो रन इज ऑन, तो जैसे ही आप अपना पेन ड्राइव लगाते हो वो ऑटोमेटिकली ओपन हो जाता है. सो डिटेक्शन ऑफ external hardwares, that is even having highest priority than the other operations. So operating system जो है वो priority पे work करता है, and that means कि operating system जो है वो प्रोसेसर के लिए कहीं ना कहीं एक प्रायोरिटी क्यू मेंटेन करेगा, so that your task can be performed based on the priority value, right? So applications of simple queues, circular queues, priority queues, double-ended queues, where? So well, you can say that in your operating system, a waiting list is being prepared for any of the tasks, and that is nothing but a queue. Even when you buffer your ऑडियो और वीडियो ऑनलाइन, जब आप यूट्यूब पे वीडियो देखते हो या तो फिर सावन पे सॉन्ग सुनते हो आप, सो ऑनलाइन व्हेन you are buffering your video or audio, then it creates a queue inside. क्योंकि ऑनलाइन जो भी पैकेट्स आपको रिसीव होंगे वो सीक्वेंस में नहीं होंगे, वो पहले क्यू में डालेगा एंड देन इट इज गोइंग टू प्रिंट प्ले इट. सो कभी अगर पता हो तो लाइट ग्रे कलर का एक बार अलग से चलता है और रेड कलर का एक बार अलग से चलता है, प्रोसेस बार नीचे, राइट? तो ग्रे कलर जो है वो आपकी क्यू है, इट हैज़ बिन क्रिएटेड टिल दैट प्लेस, बाकी जो है वो आप प्ले कर रहे हो. सो इवन CD प्लेयर इज क्रिएटिंग अ क्यू, तभी आपका सॉन्ग जो है वो सीक्वेंस में चलता है, राइट? The holding area is nothing but a buffer, right? Computer systems always have some kind of a holding area for messages coming from other hardware or coming from the network systems and all. So it always have the holding area. अगर कोई message आता है from different processes, programs, systems, कहीं से भी, तो वो holding area जो है वो और कुछ नहीं, एक queue है. It is normally called a buffer, and buffer is implemented as a queue. So these are few applications of queue, right? Few applications of queues. और application भी हमने देखी. We have looked at double-ended queue application, like you can use it to verify whether your queue is palindrome or not, and so on. So that completes our queue part. We have started with representation of simple queue, and we have started looking at operations. Then we moved on a circular queue, and we have also seen circular queue operations. And then we have covered double-ended queue and priority queue as a theory part, short note, and at last applications of queue. Right? So we complete queue here. In your second unit, linear data structures, we are done with array, stack, and queue. From the next lecture, we will start a linked list. Well, so that's all for today. Time over, so let's complete this session also. Thank you everyone for being part of this session, and see you in the next one, where we are going to start linked list. In a linked list, we will again start from the base. What is a linked list, how it can be created, and then we will have a look at types of linked lists, like singly, doubly, circular, and all. And we are going to see the operations on those linked lists, insert and delete operations, right? So that's all for today. See you in the next lecture. Bye-bye.